It's Wednesday, the 19th of June, 2024. These are the science and space headlines we're following on Talkin Science. Waking up to a view of Martian dew. An unusually leisurely neutron star, or is it a white dwarf? And NASA wants to return Martian samples to Earth sooner rather than later.
This is Trekzone's Talkin Science.
NASA astronauts Butch Wilmore and Suni Williams safely made it to orbit a couple of weeks ago aboard the first crewed flight test of Boeing's Starliner spacecraft after years of delays. NASA and Boeing are now planning no earlier than June 25 to undock from the space station and bring the astronauts home. Scientists have detected morning frost on some of the oldest and tallest volcanoes in the solar system on Mars and estimate that up to 150,000 tonnes of ice could form on them. Researchers looked at images of volcanoes in Mars's Tharsius Plateau, located within the Red Planet's tropical latitudes. The ice deposits found in the calderas of these giants, including the 21-kilometre tall Olympus Mons volcano, only appeared in the early Martian morning during the chillier seasons. The findings show the role that local atmospheric circulation above these giant volcanoes has in the active exchange of water between the Martian surface and atmosphere, the authors say. Now, the 150,000 tonnes of water ice is just a small fraction of the total amount of water vapour in the Martian atmosphere, but it could be important for local surface environments. Old satellites burning up in the Earth's atmosphere are releasing compounds that could jeopardise the recovery of the ozone hole. New international research has found that ozone-depleting compounds from burning satellites have increased eightfold between 2016 and 2022. As the number of low Earth orbit satellites with short lifespans continues to skyrocket, the pollution could increase to 646% over natural atmospheric levels. Of the 8,100 objects currently in low Earth orbit, 6,000 are Starlink satellites, but they're not the only culprits. The 1987 Montreal Protocol successfully regulated ozone-damaging CFCs to protect the ozone layer, shrinking the hole over Antarctica, with recovery expected in 50 years. But unanticipated growth of aluminium oxides may push pause on the ozone success story in decades to come. That's because the aluminium oxides contained within these satellites spark chemical reactions as they re-enter the atmosphere, destroying stratospheric ozone, which protects Earth from harmful UV radiation. The oxides don't react chemically with ozone molecules, instead triggering destructive reactions between the ozone and chlorine that deplete the ozone layer. And because aluminium oxides are not consumed by the chemical reactions, they can continue to destroy molecule after molecule of ozone for decades as they drift down through the stratosphere. Well, Equatorial Launch Australia have announced a new head of Arnhem Space Centre site operations as they continue to build on the Phase 2 redevelopment of the spaceport in the Northern Territory. Joshua Daish joins the Space Launch Facilities provider from 18 years in the Royal Australian Air Force. He's beaming in now. Joshua, welcome to the program. There is a broad remit ahead of you to grow the spaceport into a world-class multi-user commercial facility. What does that mean, and how do you tackle that?
Essentially, what we're trying to do is be the Swiss Army knife of space launch. So we want to have a facility whereby we can service multiple users. Obviously, commercial is our primary aim. Be that so we have ability to support with our launch pads and services different types of rockets and companies rather than having a bespoke launch pad dedicated to a particular rocket. What that'll do for us is allow for us to be more versatile and flexible and have a broader range of customers and an ability to support more rocket launches at a higher frequency, essentially.
Well, what excites you about the transition from planes to rockets?
They go faster, higher, better, stronger. So that's pretty exciting. I've always had a keen interest in space from a very young age. And like they say about that, the middle generation, too late to explore planet Earth, too late to explore the solar system or the universe. I feel I've stumbled across a perfect time for transition from military to commercial space in the Australian landscape, as it is anyway. We're certainly ramping up at the right time, I think, for me to make that step across.
Well, having said that, you were part of the operations management team at the Woomera Test Range, where friends of the show Southern Launch recently flew from, and you assisted JAXA's Hayabusa 2 capsule return, among other missions. So space isn't that big of a change of pace for you?
Certainly not. The main change will be probably on the other side of the fence. So with those support missions, there's more primarily working around, ground support, bringing things down, or high altitude UAVs, or some sort of futuristic uncrewed aircraft. Whereas in this case, it'll be the other end where I'll be in charge of sending stuff up, which is going to be pretty exciting, rather than simply supporting, as JAXA was very exciting, the return of the samples from an asteroid very far away, which was great to work with them on that.
Well, looking forward to seeing what's ahead. Joshua Dash, thank you.
Much better. Cheers.
Had to find the right button to press. Signals from space from a newly discovered object are challenging our understanding of neutron stars, say Aussie and international astronomers. The researchers discovered a new object called ASCAP J 1935 plus 2148, which produces powerful bursts of energy, but is strange because it has three distinctive emission states: a strong pulse lasting tens of seconds, a weak pulse lasting hundreds of milliseconds, and a completely resting mode with no pulses. This unusual neutron star is emitting radio light at a rate that is too slow to fit with current descriptions of behaviour. That's because the extreme physics with which these stars collapse results in spins on their axis taking just seconds or even fractions of a second. Now, astronomers at the University of Sydney and CSIRO have discovered this compact object repeating its signal with a comparatively leisurely period just shy of 1 hour. While an isolated white dwarf with an extraordinarily strong magnetic field could produce the observed signal, it is surprising that nearby highly magnetic isolated white dwarfs have never been discovered. Conversely, a neutron star with extreme magnetic fields can quite elegantly explain the observed emissions, but as always, more research is needed to determine exactly what is going on. Well, could Australia avoid a repeat of the devastating Black Summer bushfires of 2019-2020? Thanks to new research from the University of South Australia, Swinburne University and SmartSat CRC, small cube satellites could be the answer. Remote sensing and computer science researchers have overcome the limitations of processing the large amounts of data, not only processing it but compressing it as well, of hyperspectral imagery on board the smaller, more cost-effective Cube satellites before sending it to the ground for analysis, saving precious time and energy. We've talked about this process previously on Talkin Science. The breakthrough now using artificial intelligence and I reckon machine learning means that bushfires will be detected earlier from space, even before they take hold, and generate large amounts of heat, allowing on-ground crews to respond more quickly and prevent loss of life and property. The Kanyini mission is a collaboration between the SA government, SmartSat CRC and industry partners to launch a 6U Cube satellite into low Earth orbit to detect those bushfires, as well as monitor inland and coastal water quality. NASA is moving forward with 10 studies to examine more affordable and faster methods of bringing samples from Mars' surface back to Earth as part of the agency's Mars Sample Return program. As part of this effort, NASA will award a firm fixed-price contract for up to $1.5 million to conduct 90-day studies to 7 industry proposers. Additionally, the Jet Propulsion Lab in Southern California and Johns Hopkins Applied Physics Laboratory are producing studies as well. Once completed, NASA will assess all of them to consider alterations or enhancements to the Mars Sample Return architecture. Over the last quarter century, NASA has engaged in a systemic effort to determine the early history of Mars and how it can help us understand the formation and evolution of habitable worlds, including Earth. As part of that effort, Mars Sample Return has been a long-term goal of the International Planetary Exploration, with NASA's Perseverance rover collecting samples for later collection and return to Earth since it landed on the Red Planet in 2021. New Curtin University research could change how space missions are conducted and lead to improvements in industries as diverse as environmental management, agriculture, disaster management and infrastructure inspection. With funding from the Australian Research Council, a team from Curtin's School of Earth and Planetary Sciences has developed a breakthrough in operating and monitoring Cubesats. The project saw new algorithms created to use links between satellites to precisely determine a Cubesat's position, whether flying individually or in formation. Professor Ahmed Al-Mawafi said these improvements could help in efforts to manage climate change while also making industry more profitable. In addition, farmers can use detailed crop monitoring data from Cubesats to make better informed decisions about fertiliser use, water management and harvest planning. Well, Trekzone membership gets you in first releases and first details. Sign up today and get early access to the 21st anniversary celebration and behind-the-scenes goss on the 2024 Trekzone Fan Film Awards, presented by Mentioning Trekkie Mentions. Nothing's going to stop us. Facebook, Instagram, X, TikTok and YouTube Shorts all have podcast highlights, so find us where you are. For now, this is Talkin Science for the 19th of June, 2024.